difficulty with the third one. But second one we discussed as it is in the class. This is the same exact question. See, first question you have done it right. Why I want to discuss the second one and why am I emphasizing on this? Because this is a question from your NCERT. Okay. So this is important. Question second. This is from your NCERT. Are you listening, Basli?
Yes, ma'am.
Okay. See, this says that an electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2 into 10 to the power 4 Newton per Coulomb. Direction of the field is reversed, keeping its magnitude unchanged, and the proton falls through the same distance. Means you have two species. One is your electron, one is your proton. These are the two species, and this distance is the same. It says you have to compute the time of fall in each case. This is the one which I already told you in the class. Remember, I told you once a question came in the board exam also, who will win the race, something like this, that I have made you write as a note point in the same question which we were discussing. Right. So here, this is a back question from your NCERT. It's the same thing. See, it is at rest because nothing has been given. It is saying an electron falls. It is falling with the velocity or something has not been given. So same here also you are going to use the equation S is equal to UT plus half AT square. And one more thing, in the first question I also observed, acceleration is represented like this, not capital A. Capital A is I unit of current, which is amperes. So capital A means ampere. So always write acceleration with a small a. Once I have it at one point I have just made, rest of you can then remember. So here also see U will be 0. So from here time, now acceleration is EE. Your acceleration, remember these steps because these steps are as it is used in the, now I think you are able to relate. So you
Ma'am, what does that mean by contrast the situation with the free fall under
contrast
gravity?
the situation with that of free fall under gravity. Free fall under gravity means that time your acceleration will be equal to acceleration due to gravity. And right now your acceleration is F by M. Now, usually in case of acceleration due to gravity, F is equal to mg. So mg by m, our acceleration is equal to g. Right now, we have F by m, but our F is equal to QE. So our acceleration is QE by m. So instead of getting, see, in that case, you just have to put the acceleration as g. Now what do you have to put? You have to put the acceleration as QE by m. So your distance is equal to QE by m. And this half is also there. So 2 and this t square. So what is time equal to? The time is equal to 2 into mass into distance by charge into electric field under root. Now, for electron, proton, whatever it is, whichever quantity it is given, for these, time of proton will be 2 into mass of proton. Listen first. 2 into mass of proton into the same distance divided by charge on the proton is also fixed. Electric field is also given, right? So this you will calculate using the proton. And for electron, use the same thing. 2 into mass of electron and mass of proton. Okay, these you should remember, and see few particles, as I told you, alpha particles and all. So these will come in the magnetism chapter. So charges and all we will discuss there also. But at least the mass of electron and the mass of proton should be remembered. I'll write it here only because so that you remember. Mass of electron is 9.1 into 10 to the power minus 31 kg. And mass of proton is 1.67 into 10 to the power minus 27 kg. That's why this is more. See, less number of point. This has more number of 0.00 something. So that's why we say mass of proton is greater than mass of electron. So when it says compute the time of fall in each case, you have to calculate it like this. D by charge is also the same. So you will get the values here. Okay. This is what is the formula and the same method. Okay. When it says calculate, contrast the situation with free fall, that time you need not put the acceleration as EE by m. That will be simply under root 2 mg. Because your acceleration is just g. You won't use it. Clear? Okay, write
Yes,
down
ma'am.
these hint points. See, calculation part I'm not writing here. Everything is
Hmm.
there in the question that you will do by yourself. Okay. And mark
Okay.
this, write it somewhere. This is a question from your NCRT and it's important. Okay.
Okay.
Write this. Just quickly write it so that then you can practice it later on.
Hmm.
And then I'll discuss this third one.
Ma'am, please scroll down. Ma'am, I'm done.
Okay, this one, question 3. I hope you have written this part also.
Yes, ma'am.
Okay. See, coming to this question 3. This says that, see, it's also the same question. It's just that at one point you can doubt the electric fields unit. So I believe I have told you this when we were discussing the class of electric field, that one of the units is volt per meter. Just a second. Screen got closed. So I think I have told you that the unit of electric field is volt per meter also, but that voltage part, that we'll be doing when we'll have the class of potential. Okay, so right now you need not focus on potential part, but see, question can still be solved. If you see, you can still solve the question. How? Look, it says velocity is given as 3 into 10 to the power 7 meter per second. Okay, this is saying it is deflected by certain value. Means this is the
Hmm.
value of y. If you remember,
By plane.
we had a question where wrote we calculated the value of y, the deflection. Like this
Oh, yeah.
electron was moving and this was the deflection y, remember?
Hmm.
So y is that deflection is 2 into 10 to the power minus 3 meter given. Now distance means the value of x. X is, we have done these. All these questions are the class questions only. They are just modified questions. This question came once in the board exam. We have done a similar question to both of these, to all three of these. Okay, these are just similar. Practice these three and the two questions that we did in the class. So this topic will be clear. Practice the class questions first. That's why I always say practice the class questions first. We cover most of the things there and then go to the assignment. They are similar questions. See, this is the value of x. X is 0.1 meter. We did it in two parts because here, remember I told you, it is getting
Hmm.
deflected. So it's like a plane. So we have to do x separately, y separately we did.
Yes, ma'am.
Yeah. So see, just one thing here, it is important that you should know. Electric field is given as volt per centimeter. So we don't want how much is there in 1 centimeter because everything is in meters. You have to write, I mean, in SI unit. So that will be 1800 volt per meter. So use this value. Obviously, how will you convert meters? It will become 1800. That's it. See, if you remember, the first step that we did was along x-axis, we calculated the time as x by v.
Hmm.
Remember? And when we calculated the distance y in this, I'm not doing it in detail because I'm giving you the reference class notes. Okay. So y is what? Y was half a t square. And t square was from here x square by v square. And I left the answer till here because that was our whole question. Now that it's the same question, it has just given you the value. This is velocity, this is distance, y is given, you know. Now what you have to calculate? You have to calculate, determine E by m of electrons. What is
What's E by
acceleration?
M, ma'am?
E by, right? It's E by m only. So from here, if you look,
Oh,
got it?
I got confused there, ma'am. I didn't know what to calculate there.
So see, it's actually like E by m is the acceleration, x square by v square. So the question is saying, a question is asking you to calculate this. That's it. So what you have to do, you have to just transfer everything on the opposite side. So your E by m will become 2v square y by e into x square. Everything is given. So this is one catch of the question which you need to know. And this is one catch of the question that you need to know, which is something different. So you tell me, Basmi, was there anything that I told you something very different in a method or something? No? These are from the class notes only. Practice, see, after every class note, whenever you're going to sit for physics preparation or whenever you are studying for physics, because obviously every time you cannot, the whole time you cannot study physics. You have to manage other subjects, school homework, school tests, and now you're having extra classes on Saturdays also. So study physics first. Means whenever you study, study the class notes first. Once class notes are done, then you go to the assignment questions because these are selected questions that are given as assignments. Practice them, whatever doubts are like this, they are getting this. So at least now your concept is clear. You know how to manipulate. Okay. So just write it properly. I've written in a very haphazard manner. You please write it in a sequence. Then I'll start with electric flux. Could you revise anything from flux because you had the class today?
No.
Okay. Anyways, we'll continue with Gauss law today.
No, ma'am.
Okay, coming to electric flux, which we discussed yesterday. So basically what we discussed, let me just give you a quick recap, so at least your revision is done here. So see, for electric flux means number of field lines that are crossing area normally, means perpendicularly. Okay, so that is basically what is meant by electric flux. When you calculate mathematically electric flux, it's the dot product of electric field into the surface area. And how do we open the dot product? By writing the magnitude of electric field, magnitude of surface area into cos theta. Important here is that electric fields and surface areas magnitudes are taken. And this is very important, that this is not just any angle which is given in the question. Like whatever data we see in the question, we are in a habit of writing it. But here we have to be careful because we first have to drop an area vector here. That is the perpendicular. And the angle which is made between the electric field and the area vector is what is the angle that we consider. So this is the flux that we write. Okay, so this we discussed, and the questions also we practice these questions properly. And I have given you 2 to 3 questions in the assignment. Okay, so that
Okay.
that assignment, electric flux, and today I'll give you assignments on Gauss theorem and charge distribution. Those two I'll discuss it on the next Friday. Okay.
Okay.
So together I'll discuss or try to ensure that you submit both of them together. Okay. Or
Sure, ma'am.
whenever, however you feel comfortable. It's not compulsory to submit it both on a single day, but at least try to attempt it. Very less questions will be there. I'll increase the questions from this topic, Gauss law. Okay, more. Electric flux just has 3 questions. I think by now it must be there in your account also. So yeah, one thing I was telling you regarding the surface integrals. This is important because now we'll be getting introduced towards the Gauss law. So pay attention here. When we're talking about the surface integral, I told you yesterday, if the surface area is curved or you have a variable surface area, then you integrate, right? For the flex. Remember I told
Yes.
you the point, yeah? So see, what happens? Electric field is constant. So electric field comes out. And what are we left with? Integral of the surface area. So if it's a sphere, your integral, closed integral, surface integral basically becomes 4 pi r square. This becomes, because this is a surface area. Surface area of a sphere is 4 pi r square. And similarly, if a cylinder is given to you, these are just some 2 important note points because these are often used. So when we're talking about the surface area of these, integral of a cylinder. Yes, this you tell me, what should I write? Surface integral.
Pi r, 2 pi r.
2 pi r. That's the circumference of the circle. Till here only you have told me. What about the length? 2 pi rl. Pi r square L is the volume of the cylinder. 2 pi rl is the surface area of the cylinder. Okay. So like this, you have 3D shapes, you know their formula, you can apply that. Now a very important, very easy, but very important question we are going to do. It says that a charge Q is placed at the center of a sphere. You have to calculate the flux through it. This is what it is saying. So let's see, this is our sphere. Okay. And at the center of this sphere, we have put the charge plus Q. It is placed at the center of the sphere. You have to calculate the flux through it. So we, again, this is the curved surface area and everything. So we have to consider a small portion, which is ds, and this is our n cap, right? So when we are calculating the flux, electric flux's formula is E dot ds surface integral, correct? Now see,
Yeah.
electric field is present. This is phi is equal to E dot ds, right? Now you have to introduce the electric field. We have to put the value of electric field also, right? And the surface area also. Because how do we know electric field is constant or not? So it is a simple question. A charge is there at the center. Let's say some radius is present. Let's say the radius is, we are assuming the radius is r. So let the radius be r. Okay, this is the radius. Charge Q is placed at the center of the sphere. This line also needs to be mentioned once written. Now, Basmi, tell one thing. Electric field will be,
F by Q.
okay, and F is
F is
electric field due
4.
to a point charge. This
Oh,
is
okay. So KQ by R square.
right. So K I am writing as 1 over 4 pi epsilon naught. So K charge is Q and this is R square. See, till here also separation will be R only, no? And we are calculating at this point. So it is R square, correct? So this is electric field. And similarly, if this electric field is taken out, it means E is taken out. We now see, we can see electric field is constant. We'll be left with integral of surface area. What did we discuss? What was the surface area?
4 pi R.
4 pi r square. You have mathematics, Vasmi.
4
4
pi
pi
R square.
square. E into, you are left with 4 pi r square. Let's put the value of E. So we get q by 4 pi epsilon naught r square multiplied to 4 pi r square. R square 4 pi r square gets cancelled. Flux is equal to q by epsilon naught. Is it familiar to something? This is actually your Gauss law. This is the Gauss law, right? You must have heard it in your school, Gauss.
Yes, ma'am.
So this
Yes,
is what
ma'am.
this we did it in the form of a question. So it's a question from flux. Okay, it can come as a question of flux with some modifications. Electric field can be modified, the charge can be modified, something can be there. But apart from this, this was the derivation of Gauss theorem. So this is your, that's why I said write all these things, let RBI. So this is basically the derivation of Gauss law. Derivation of Gauss law is done. What is Gauss law now? We can conclude. See, Gauss law says that whenever you have a closed surface, across the closed surface, the total flux means this phi. This is given as 1 by permittivity times 1 by epsilon naught times means you are multiplying, right? Times 3 times 4 times. So 1 by epsilon naught times the what? The charge which is enclosed within the surface, not any charge that is enclosed. This is what is meant by Gauss law. So our electric flux becomes charge divided by epsilon naught, and epsilon naught's value should be remembered because the questions will say what's the value of epsilon naught.
8.23.
8.85 into 10 to the power
85 10 to the power minus 23.
minus
20.
minus 12. Don't forget the
Oh,
value of epsilon naught. Epsilon naught, K, E, the electronic charge. These things are important. Now two things are also added after today's homework. Mass of electron and mass of proton.
oh,
Remember that also. 1.67 into 10 to the power minus 27 kg for proton and 9.1 into 10 to the power minus 31 kg for electron. Just remember after the class, whenever you go for self-study, that time add that also. And I think it's better, Basli, somewhere write all the constants. So when you're revising for the tests or the exam, final exam, you have the constants also written.
Ma'am, I already started writing it. I
Okay, you
mean, for the
started?
last test, I wrote it. I wrote all the things for the last test. I didn't write all of this yet.
Okay, great, great. See, right now it will look a very tedious process, but towards the end, you will find everything written in a concise manner. So the last moment revision is done through that very helpfully. So see, what is the Gauss law? The statement only, according to Gauss law, electric flux through a closed surface is 1 by epsilon naught times the total charge enclosed by the surface. So write it till here, then we'll see what are the properties of Gauss law.
Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, I'm done.
Done?
Yes, ma'am.
Okay. See, the properties are very easy of the Gauss law. First property says that whatever be the shape, because see, ultimately, why did I say that this was the derivation? I just took a sphere. Even if you take a cylinder, you take any object. What happens is the final result that you're getting, that is simply q by epsilon naught. It is depending upon the charge enclosed, and epsilon naught is constant. So it means you take a cube now, you take a cuboid now, you take any shape, it will still be q by epsilon naught. Charge is q, radius is r, flux will be q by epsilon naught. I double the radius, it will still be q by epsilon naught till the time it is holding the charge q. I take a rod with a charge plus q, flux will be q by epsilon naught. A random shape is taken, it is q by epsilon naught. First property is clear? Okay. Second says you just have to take the charge which are enclosed. If some charges in your system are lying outside, you're not going to consider them because it's a property of closed surface. If it wasn't a property of closed surface, we wouldn't have reached to this conclusion because we just took the charge that was present at the center of the sphere. So your charge enclosed will be Q1 minus Q2 plus Q3. So flux will become Q1 minus Q2 plus Q3 divided by epsilon Not, right?
Mm.
And see, outward flux will be positive and inwards flux will be negative. All right. The properties are very easy. Fourth point says that this is important. This is important. Why? Because this can be helpful in your numericals. This is like, it is saying a surface is present and electric fields are just crossing across the surface. It's like, see, this is the surface. Okay, this is the surface. And electric field lines, they are crossing, they are just crossing the surface like this. This is how the electric field lines are moving, like this. So what happens is, two methods are there by which you can relate this. One is that if there isn't any electric field crossing the surface, this is like this. Electric field is just passing across the surface, right? So if this is the case, when electric field is just passing across it, what are the number of field lines that are going inside if it is just passing?
1.
Number of field lines perpendicular to the surface. How many?
None.
Zero, nothing. All the field
Yeah.
lines, see, this is the electric field. Imagine this is the electric field, this pen, and this phone is the surface area. Electric
Mm.
field lines are not going like this, or to any angle with a perpendicular, nothing. They are like this.
Mm.
So what was the definition of electric flux? Electric flux said number of field lines crossing perpendicularly. Those are only considered as electric flux, right? So
Mm.
if there isn't any electric field passing, electric flux is zero,
Mm.
right? Secondly, how can you explain this to someone without explaining like this, right? So one thing is that if electric field is passing like this, okay, our electric field is just passing like this. But for the calculation of Gauss theorem, we require area vector first. Area vector will be perpendicular to the surface like this, right?
Yeah.
So what's the angle between electric field and the area vector?
Plus
How much?
0. 90 degrees.
90 degree, right? Electric field is crossing like this,
Okay. Yeah,
perpendicular,
it's 90 degrees.
right? And see, if we have theta as 90 degree, cos 90 becomes 0.
0.
So entire fluxes, which is Es cos 90. So this way also, mathematically also it is coming 0. And theoretically also it is not crossing perpendicularly. So anyways, it is 0, right? Got this?
Yes, ma'am.
Okay. Now tell me, if a dipole is present, what's the net charge?
Net charge is dipole is 2A into Q.
I'm not asking dipole moment. A dipole is present. What is the net charge?
Net charge will be uh 2Q.
How?
Oh wait, it will be 0. Nah, I'm confusing force and all. It's 0, ma'am.
It's 0. Minus q plus q, it is 0. So
0.
if a dipole in any surface, the flux will be 0. Because your q enclosed is 0. Right?
Hmm.
This is exactly our q enclosed. Got it, Basmi? All the
Yes, ma'am.
properties now. Write them, and then we'll practice now. Questions? You've understood everything till here?
Yes, ma'am.
Okay, please write.
I'll put out. If the charge is negative, you take minus q by epsilon naught, right? You don't take the magnitude.
Basmi, can you repeat?
Ma'am, uh, when you take, if the charge is negative, you take you don't take the magnitude, right? You take it
No.
with the
See,
sign.
when you are calculating the net charge, that is solved through
Uh,
the property of additivity of the charges. That's what we were studying. That electric charge is scalar. So we don't have our concept of superposition principle where we need to use the parallelogram law. So direction and they are separate. So charge is scalar. If it's negative, you have to subtract. Same thing you will see in potential.
okay, ma'am. Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, I'm done.
Okay, let's discuss the questions now. Okay, this says these kinds of questions often come where a shape will be given to you and it will just tell you to calculate the flux through one side of it. Like, see, calculate the flux through the cube, but second part says flux through each face. See how you have to handle these questions. The first part is very easy. Flux through the entire cube. What is it? Tell me.
0.
Zero. Charge is present in the center.
Yes, ma'am, but then, okay, it's not 0.
What was Gauss law?
Gauss law was Q by epsilon naught.
So that was what was the statement of Gauss law. This is what it said. We discussed that this Gauss law says that electric flux through a closed surface is Q by epsilon naught. So that cube is it open from some side?
No, ma'am. But then I thought that property 4, since it's closed and it goes through it, so maybe it might be
No, no, no,
0.
no. A cube is there, and inside the cube, a plus Q charge is present. So it's a closed
Hmm.
surface. It's not open from any sides, right?
Hmm.
So flux will be simply plus Q. It is given by epsilon naught. That's it. Why will it
Oh.
be zero? It is a complete enclosed surface. This is what you have to ensure, that the
Hmm.
surface which you are taking should be closed. If it is not
Hmm.
closed, then you cannot apply. Now, second
Hmm.
part is tricky. It says flux through each face, means flux through one face of the cube. Now, this is something different. It's like, suppose this is just one side of the face of the cube, and plus Q is somewhere here. This is what is there inside if I just take one of it, like
Hmm.
this. So is this a closed surface? This isn't a closed
No.
surface. So we cannot use Gauss theorem like this and answer something. This won't be helpful. So what can we do?
Hmm.
Let us expand this definition for the second part. Pay attention, one question you have to answer.
Hmm.
See, this is saying Q by epsilon naught was what? Flux. Now be
Yeah.
alert. This is saying flux through the cube is Q by epsilon naught, right?
Hmm.
When I say a cube means how many faces?
So 6 faces.
How many?
6, 6.
Six faces, right? Six faces makes one cube. So six faces make one cube. So if I say flux through the cube is this, it means flux through six faces are, flux through six faces is Q by epsilon naught. I can write cube as 6. One cube has six faces. So
Hmm.
I can replace the term cube with this one, six faces, right? And the
Hmm.
question is asking for one face. Now can we answer?
Hmm. Divided by 6.
Divided by 6. Flux through one face will be
6
Q
Q
by
by
6
epsilon.
epsilon naught. This is the answer. Got it?
Hmm.
So we are going to start with this only because you cannot use Gauss theorem for this. And technically, what are we doing? I'll tell you one more thing. We are actually imagining we are placing 6 more faces like this to enclose it.
Hmm.
That's why Gauss theorem is still applicable at the last step. We are getting a similar
Hmm.
answer. It is like we have put 6 more faces, 6 more imaginary faces. So what happened? Flux through the cube became this. Okay, write it. And the second question you answer. Okay.
Okay.
But first write down the first one.
Ma'am, can you scroll down?
Don't take much time in this. It's very easy. Just apply the same method. Try it
Okay, ma'am.
first by yourself. Take 1 or 2 minutes, but at least try. Then I'll discuss.
Just the formula itself, flux is equal to Q by epsilon naught.
How much, Basmi?
Flux is equal to Q by epsilon naught itself.
This is your answer. Flux is equal to Q by epsilon naught. This is the answer.
Uh,
Okay.
hmm,
This is hemisphere. Is hemisphere closed or open?
close, right?
Inside the hemisphere, it is not saying that it is inside the hemisphere. It is saying at the center of a hemisphere. It
So
is
it's
like
not full.
if you have, see, if the question said inside the hemisphere, then hemisphere, we know it's a closed figure. It's a
Mm,
proper shape. Hemisphere is a shape
mm,
included, but it is not saying inside it. In the previous question, it mentioned it that the flux is inside, right? Flux was in, sorry, charge was inside. It is saying it is at,
but it's placed at the center, right?
so it is not applicable for Gauss theorem. So you cannot, this is a similar question to the second part. This was also not applicable. What did we do then?
We closed it.
Exactly. So what should be done here? How can we close
This
it?
is sphere,
Okay, if we close it, what kind of figure we'll get?
a sphere.
A sphere. So if I, okay, let us imagine this is a sphere, we have closed it. It's a sphere. So what will be flux through the sphere?
Q by epsilon naught.
Exactly. So what you answered me was flux through the sphere. So flux is made up of how many hemisphere?
Two. So 2 EQ by epsilon naught.
Yes, so we can say flux through two hemispheres is. Actually, what are we getting as Q by epsilon naught? So flux through one hemisphere will be how much?
Q by 2 epsilon naught.
Yes, got it right.
Ma'am, I'm done.
Done?
Yes, ma'am.
Okay. Let's move to the next question. Okay. This is again a question from NCRT. This has come in the board exams also. And for you, I'll tell you this question has come in the JEE mains also. So see, it's a very easy question though. When you look at it, it will become difficult. By looking at it, okay, a cube is present on a graph and the coordinates are there. No, we are going to follow our steps, whatever we have studied. The same properties. That's why we study the properties, no, so that you are aware how you have to apply the things. Instead of giving you the direct value of electric field like 10, 14, 18, like this, it has given you the variable electric field. That's the difference. Alpha is x to the power half. X means x coordinate. Okay, now you have to be a little imaginative, okay? and you have to think electric field is present. Now, what it is saying, electric field exists along x-axis. So one thing, have it in your mind that electric field is present along x-axis. This is electric field. It's variable. It's given in terms of x, and this x we will see later. Now we have to calculate flux through the cube and also charge enclosed. Main task is first flux. Now look, this is the electric field. Let's see, these are how many surface area. How many faces are there in a cube?
6.
How much?
6.
6 faces are there. Now see, when we are talking about a cube, let's say this is, just imagine this is a cube, right? Now see, along the x-axis, you have the electric field line going. So this is the electric field line, okay? Let's check the front face first. Okay, this is the front face. Electric field is present like this along x-axis. But for our flux, electric flux, which angle do we consider? Should we take this as 0? We drop the perpendicular first. So what's the angle between area vector and electric field now?
90.
90. Because electric field is along x-axis, positive x-axis. Area vector for this front face, this is upward, see, like this is 90. This view you can see this is 90. This is coming towards you, right? And this is towards the opposite side. So this is 90 degree. Okay. This was the front face. Let's talk about the back face. Okay. Let's say this is the back face, right? Which you can see. Again, electric field for the back face is also towards the right. And area vector will be outwards. So angle will be
90
degree. Okay. Let's talk about this top face. Electric field is towards the right. Electric field cannot be changed. Area vector for this one will be upwards. Area vector for this top face will be upwards. Angle?
90 degree.
90 degree. Let's come to the bottom face. Electric field is towards the x-axis, right? Now, when we drop the area vector for this surface, perpendicular,
it will be
90 degree. So one thing we can conclude is for all these 4 faces, electric flux will be 0, EA cos 90 degree. Got it? Now we are left with 2 surfaces. 4 we discussed. Let us check for the right and left. Okay, this is the left. For me, this is the left. I don't know how it is coming in the camera because it sometimes rotates. No. So electric field is along the x-axis. This is the area vector. What's the angle?
180.
180, right? So this was my left face and this is the left face here also. So what is happening? Electric field is inside and the n cap is present here. This is 180 degrees. So this we have to consider. Let's see the right face. Electric field is along the x-axis. Area vector is here, perpendicular. What's the angle?
0.
0 degree. Cos 0 is not 0. So it means we have to consider this face also. So when we are talking about the right face, this is electric field, this is n cap. So this will be considered. And for the rest of it, see, because it is difficult to draw for all the faces in one figure. Right now you will understand, but when you will revise, you will not understand what you have written. So that's why I made you understand through this. Now you can just write it somewhere in the corner of your notebook or here only, so that you understand why is it 0 for all. Like n cap will be here, electric field is here, angle is 90 degree. Now for front and back, I'm not writing. It will be very confusing for you to understand, but you have understood?
Yes.
So what's the conclusion? One conclusion is that electric flux is 0 for the 4 faces. Second conclusion, left and right are existing, correct? So we have to calculate the flux for the left face and right face. Let's do that. Then we'll add it. and then we can calculate the charge later. Okay. So flux through the left face. Flux through the left face I am calculating. It will be electric field into surface area, right?
Yes, ma'am.
ES cos, it is 180 degree. What is cos 180, Basmi? Mathematics girl, answer.
1 or -1, I don't remember.
-1. See, Basmi, these things should be remembered by you. And not just because you have maths. Even if you had bio, you had to remember these, right? Revise these basic things. See, this is what is the mistake. I find it in your assignment also. You're able to do everything well in the class, but small error. In one assignment, you have written cos 60 degree as √3/2, something like this. So just be careful with your calculations. Be alert while solving. It is -1.
Okay, ma'am.
So this is minus E or A into S. Now, electric field is given as alpha x to the power half. And surface area, see, side of the square is A. So area will be
Area will be A square.
A square. Now, we have to determine this x. X means the separation, the coordinate. So for the left face, what can you tell me about the x coordinate?
X coordinate is A, 0.
A, 0, right? It means this is x, this is A, right? For the left face. So I have the value of x as A. So it is minus alpha A to the power half dot A square, right?
Yeah.
When bases are same, powers get added up. So this will be minus alpha A half plus 2, 5/2. This is the flux for the left side. Now let's come to the flux due to the right side. So in the right side, it is ES cos 0 degree. Cos 0 is +1, okay, not -1. -1 is this. So this will be ES. Now, electric field is minus alpha x to the power half. Now, surface area for the second face also will also be A square only. But tell me, Basmi, for the right side, what is the value of x that I should put?
For the right side value of
This is the
A
right.
is 12.
It will also be A. What's the coordinate of this?
Oh, 2A.
2A. This will be 2A. It is like on the axis, a sheet is placed. You can imagine it. See, if this is the axis, now we are not talking about the cube, we are talking about the face. So it's like one face is present like this, right?
Yes,
Left is
ma'am.
present like this. So you just have one sheet which is present, one face is present. And once the face is present for you, you just have to look at the coordinate, right? You just have to
Yes,
look at
ma'am.
this coordinate, correct? So that is 2A. So this will be minus alpha into 2A to the power half dot A square. Again, this is half plus 2 minus 2 alpha A to the power 5/2. Net flux will be left plus right. So actually it will get subtracted. No, both are negative. No, this is positive. Is the electric field given negative? No. This will be positive because cos 0 is 1. So this will become positive. So this will be 2 alpha A to the power 5/2. This is negative because of cos 180 degree. So minus alpha A to the power 5/2. You can simplify it. It's very easy to understand. 2 something in minus this, that gives you simply alpha A to the power 5/2. This is the flux. Got it? Now, second part says charge. Flux is charge by epsilon naught. So charge is flux into epsilon naught. Most of the questions have this step. They always ask what is the charge after calculation. So simply you multiply epsilon naught with this alpha A to the power 5/2, this much of coulombs, and this will be Newton meter square per this much. This is the charge. Now, sometimes questions give the value. We have done the toughest question. Now, Beyond this, from the cube part, nothing is possible. So practice this properly. Did you understand this?
Mm. Yes, ma'am.
This charge step you have understood?
Hmm.
Oh, write it, please. Uh,
Ma'am, can you scroll down? Ma'am, I'm done.
Okay, Basmi, from electric flux only, I have given the assignment today. 4 questions I have given. I am repeating,
Okay, ma'am.
practice the class notes first. You will be able to do the
Hmm.
homework questions. And
Okay, ma'am.
don't take the help of internet. The way you have been
Hmm.
solving it honestly, solve it the way. Even you are not able to do, we will discuss it in the class, okay? But see,
Okay,
your
ma'am.
homework will be uploaded by tomorrow, today's homework. So you have this full
Hmm.
practice it because we are towards the end of chapter, right? And we have done many
Okay,
things.
ma'am.
So I want you to have this chapter, a great grip on this chapter, right?
Hmm.
And do let me know about your tests also, so that I can prepare
Hmm.
you accordingly. Okay. I think after 8th May, I'll take your extra classes because chapter 2 will
Okay,
definitely
ma'am.
come in your exam, right? UTs should be prepared. But yeah, right now I am also not available. Otherwise, I would have taken this Friday or some other day. Or what we can do,
Hmm.
we can increase the duration. This is what we can
Hmm.
do on Fridays at least. Let us see, that I'll discuss later. But till 8th May, let me know whatever hints the school is giving you. Okay. See,
Yes, ma'am.
continuous charge distribution is important for you to derive the application. Last topic is left, that is application of Gauss law. So
Hmm.
for applications, you should understand what is meant by charge density. Charge
Hmm.
density, this topic is the easiest. If you just pay attention, it's actually the easiest. See, linear charge density, you have three charge densities, okay? 1D, 2D, 3D. 1D means straight line is present. 2D means surface area comes. 3D means volume comes. Means one dimension, so linear. 2 dimensions, so aerial. 3 dimensions, so volume. Now let's start with linear charge density. Linear charge density means you have a linear surface, and on this linear surface, how much charge is present per unit length. Means if I take 1 meter, in this 1 meter, how much charge is present? That is called linear charge density, charge per unit length. Okay. In simple terms, you have charge per unit length. You represent it by lambda. So charge per unit length. So most of the questions are solved using this. Charge is coulomb. This is meter. So unit is coulomb per meter. Most of the questions. But now in class 12th, every question won't be this simple. You have variable lengths, variable charges and all. Okay. So if you have anything variable, then you differentiate dq over dl. This is for variable. And this is for constant. Got it?
Yes, ma'am.
Show you this. Wait. See, this says a charge 10 coulomb is uniformly distributed on a wire of length 5 meter. Now, Basmi, tell me the steps. Linear charge density. What was the formula I told you?
Q by L. So
Q by
10 by 5.
exactly. So Q is 10 coulomb, length is 5 meter. So this becomes 2 coulomb per meter. Easy.
Okay.
This is done.
Hmm.
It says charge on 2 meter length of wire. So we will go by unitary method because this is also constant. You need not differentiate
Hmm.
it here, right? It is saying 10
Yeah.
coulomb is here, calculated on 2 meter length of wire. So see, you have the charge as 2 coulomb. You have to calculate it on 2 meter length of wire. So you can, now I am telling you something else because if the question becomes tough and you're not able to identify, right now it's very easy to understand. What you do, you take the unit example. If in 1 meter, 2 coulomb is present, right? So in 2 meters, how much will it be present, right? If in one
Hmm.
meter, 2 coulomb is present, so in 2 meters, 4 coulomb per meter will be present, right?
Yeah.
Sorry, not coulomb per meter, 4 coulomb will be
Okay.
present. Because it didn't ask you the charge per unit length, no. If it asked the charge per unit length, it would have been directly 10 by 2. Yes, 10
Hmm.
is the
Yes,
charge,
ma'am.
with the length, 10 by 2. But right now it is saying charge on this much length of wire. Okay, 1 meter has this much charge, 2 meters will have 4 coulomb. Easy?
Hmm.
Okay.
Yes, ma'am.
Uh, write it till here. If time is left, then I'll tell you about the variable one. Okay, but first make this.
Okay.
So next Friday on 25th April, we'll complete this chapter, and 26th I'll start with potential.
Okay, ma'am. Ma'am, can you scroll down? Ma'am, I'm done.
Okay, Basmi. So, but time is almost up, so we'll not be able to complete the next question. See, what I expect from you this week. Now you have 1 week time. We'll have the class directly on 25th now, right?
Yes,
Assignment should
ma'am.
be done, but before the
Hmm.
assignment, you should practice everything and revise and come. Okay?
Okay, ma'am.
Guys, you will be able to relate. I understand yesterday was the class and today, so of course you couldn't revise yesterday's portion. But now you have time, yesterday's, today's, whatever, and see whatever doubts you have from the complete chapter. Also, if you want me to revise anything or any topic you have any difficulty, let me know. Okay, but
Okay,
revise and
ma'am.
come. Gauss law is the most important topic. If you are
Hmm.
revising for the board exams, last days of board exams, I will suggest you from the first chapter start with Gauss law. This is that
Okay,
what
ma'am.
somebody has to give a question from electric charges and field. They'll give you questions from Gauss